Alright, so this is number 4. I have y equals x. This is the one we started working in class, but I feel like I need to go back over with you a little bit more to make sure you understand. So we're going to do the first derivative test here to determine the extreme values of the function and any absolute extrema. So what I want to do, of course, is the first derivative. So I'm going to do product rule, the derivative of the first times the second plus the first times. And when I do the derivative of this e to the 1 over x, I'm going to do e to the 1 over x, and then I have to chain rule it, of course. Remember, 1 over x is the same thing as x to the negative 1. So that becomes, the derivative of that would be negative x to the negative 2. I'm just going to clean this up just a bit. E to the 1 over x. This is going to be a minus because of the negative here. So I've got e to the 1 over x, and then I've got this x to the negative 1. So what I'm going to do, I'm going to take out an e to the 1 over x, because remember, I want to know where this equals 0. So when I take this out, I end up with 1 minus. I make this 1 over x instead of x to the negative 1, just for the sake of simplicity as I solve this. All right, so zero product property tells me that one of these two has to equal 0. And this is never going to equal 0. There's nothing I can plug into x in order to make that become 0. So I'm only going to look at this piece, 1 minus 1 over x equals 0. And so as I solve this, I get 1 equals 1 over x, which of course means x equals 1. Now, as you look at this one, I'm thinking about my sign analysis here, and I am going to put a 1 on it, but here's where you have to stop and think also. I need to stop and think about any points where I am undefined in my derivative. So looking at the derivative, which is here, the only place that I would be undefined, of course, this is a little more simplified version of the derivative, is if I'm dividing by 0, right? And the only time I'd be dividing by 0, this is actually e to the 1 over x. Now, this is an easier one to look at. But I can't have an x in the denominator here or here. So I need to look at where x equals 0 as a test point also. So I'm going to put a 0 here. And now I'm just going to go through and I am going to test these intervals. Now, what happens is whenever I plug in a value over here, I get a positive. But this is a discontinuity. Okay, this is a place where if you look at the graph of this, and let me just pull up quickly what the graph looks like here so you can see what exactly is going on. If I have x times well, I'll just do it this way, times e raised to the, and then I'm going to do 1 over x here, 1 divided by x. What you'll see is this is an endpoint here, and my function stops, and then I come here. So what I should find is that I have a minimum value here. That should be my 1 value that I found on my derivative equaling to 0. But of course here x can't equal 0 because I would have that 0 in the denominator. So I'm going to continue on. My derivative here would be positive if I plugged in a value, negative, and then you should see it being positive here. The endpoint here is, like we said, a discontinuity. But at the 1 value here, because my function is decreasing and then increasing, and again, you can look at the graph and you can see it is a minimum. So I can call, there's a minimum value of, and I need to say what that value is. So I need to find y of 1. So again, back to the original equation, which is x times e to the 1 over x, and I plug 1 in there and I get 1 times e to the first, which is just e. So I have a minimum value of e at x equals 1, or I have a local minimum, either one of these would suffice, at 1 e. Okay. Let's see, and of course we would say because the sign of the derivative is changing there at that point. All right, number 5, and this is the one I really want to get to talk about because we started talking about it this morning and we kind of get sidetracked, so I want to finish it. You're welcome to watch if you want to. You don't have to. This is the one we started. So we're doing first derivative test on it. So I'm going to find the first derivative. We're still going to go through all of that. So derivative of the first times the second plus the first times the derivative of the second, 1/2 times 8 minus x squared, negative 1/2. And of course the chain rule on that, which would be negative 2x. All right, so because I know that I have to find where it equals 0 and points where it's undefined, what I'm going to do, this 2 and this half is going to cancel. I'm going to change this to a minus. This is still the same way we did it in class. I'm going to put this over. All right, here's my derivative. This, of course, because of the one. Because I'm looking for where it's 0 and it's undefined. I'm going to make this one big fraction. That way I can see, because when my bottom's 0, that's going to give me my undefined points. When my top is 0, that's going to tell me when the value of the entire thing is 0. So if I give it a base of root 8 minus x squared, top and bottom, I end up with the fraction.
How do you know to do the square root 8 minus?
So I'm just trying to get it into one fraction, because if I can get it into one
If you
fraction,
consolidate, it's easier.
right? Okay. Because I know if I've got a fraction, so I've got something up top, something on the bottom. When does the fraction equal 0? Well, fraction equals 0 when the top equals 0, right? Well, where is it undefined? Well, it's undefined when the bottom equals 0. So by getting it in a fraction, I can kind of, in one single fraction, I can kind of kill two birds with one stone. So the square roots cancel out, right? So I've got 8 minus x squared over square root of 8 minus x squared. So now I have common denominators, right? And I can combine them together. So my derivative here, 8 minus 2x squared over square root of 8 minus x squared. So first derivative test, where is it 0? So it's 0 when the top is 0. Where is it undefined? It's undefined when this is equal to 0.
And you got to solve for both of them.
Then you got to solve for both of them. All right, so 8 minus 2x squared equals 0. Subtract, or I'm just going to add 2x squared. So I've got x squared equals 4, so x equals plus or minus 2. But I've got to take these into consideration as well, because those undefined points. So I'm going to square both sides and have 8 minus x squared equals 0. So now I have plus or minus square root of 8. Negative square root of 8, negative 2, 2, square root of 8. So again with the derivative and looking at the function. Now I test these points, and in the case of this one, these are actually endpoints. It's not going to go past because I can't have a negative number under my radical, right? So I really need to keep this greater than or equal to 0, and whenever you go through and solve that, you'll find I'm between these two values. So these are actually endpoints. So, which is an important point because I'll have to test those endpoints to see what the value of the function is there. Okay, between these two, I don't know. I can't remember what we got.
I'm trying to figure out.
When you plug this back into the derivative, you will find that between negative root 8 and negative 2, you are negative, which means my function is decreasing between negative 2 and 2. So maybe 0 is a good test point here. You are positive, which means increasing, and then here again, negative. So I have two values. Well, actually, I'm going to have to test these points. So I will test negative root 8. I will test f of negative 2. I will test f of 2. And I will test f of the square root of 8. So, and I know I'm going between f and y, but what I'm going to do, I'm going to, just for the sake of example, because of time restrictions, I've got my calculator and I've got it plugged in to y equals, and I'm going to go into my table and I'm going to put negative square root of 8, and I get 0, and then if I put negative 2, I get negative 4, and if I get 2, I get 4, and if I put in the square root of 8, again, I get 0. And so this graph comes out looking a little funky, actually, if you look at it, and it does a little something like this. And so these are those max and mins that we just found. So I have a minimum value here of negative 4 at x equals negative 2. That is this point. And then a maximum, absolute maximum here at 2 that is positive 4. And of course, that's where the signs are changing there for the derivative, and it gives me the minimums and maximums. Moving along, let's